This is Chapter 9, Exam Review, looking at quadratic equations and functions. So lots of parabolas here. So 9.1, looking at our basic equation, y equals ax squared. So we're going to complete the table for the parabola. So they tell us it's a parabola, which means it's going to have a middle point that mirrors itself on both sides of the axis of symmetry. So since we see a 5 on both sides here, we know that 0, 0 right here is going to be the vertex. So we can go ahead and answer that question. And then from there, we're going to have the same numbers as we move side to side. So the first two numbers for 1 and -1 are 5s. And so for 2 and -2, they're going to be the same. So 20. And for 3 and -3, they will be the same. So 45. And for 4 and -4, it is 80. And so if you thought about this on a graph for a second, you've got a 0, 0, you've got a 1, 5, and a -1, 5, you got a 2, 20, on and on and on. They're going to keep going like this. Okay, so you have a parabola, swoops up like this. The axis of symmetry cuts this in half, basically, so that these two sides mirror each other. It's symmetrical on both sides of that. So this line right here, any line that goes straight up and down, like if this hit at, say, I don't know, 100, that line, anywhere I go on it, I'm going to have a different y value, but my x value is still going to be 100. This would be 0.0, 100 down here would be, say, -100, 100, but notice the x value is still 100, and up here you could go to 50, 100. So the y value goes up or goes down or it's at 0, but the x value stays at 100. So the equation of that line would be x equals 100. So the equation of this line that goes straight up and down and hits the x value of 0 is x equals 0. That's the equation of the line that cuts this in half symmetrically, and that is your axis of symmetry. All right, moving on to 9.2, we're going to solve these equations. So we've got some square roots to take at the end of these. So first thing we always want to do is isolate the x. So we're going to go ahead and divide by 5 to get rid of that coefficient. So x squared equals 20. We're going to go ahead and square root now to get x by itself. So the square root of x squared is x. And it doesn't specifically say how to leave your answers. So we're going to go ahead and take the square root of 20. And we'll round it off, because that's what the answer key did, so 4.5. And so this is plus or minus, because remember, a square root can be the positive or negative, 4.5. You could also leave it as radical 20 and simplify. If the directions said leave it in simplest radical form, you'd split this into square root of 4, square root of 5, because the square root of 4 is 2. And so the final answer would be 2 square root of 5. But since this hasn't specified, I'm going to go by what the answer key has gone by, because that's probably what you were looking at. And so we're going to go with the decimal version of plus or minus 4.5. All right, so we move on to the next one. We're going to try and isolate that x. So first thing we're going to do is minus 42 on both sides. So that will leave us just a 4x squared. So 67 minus 42 is 25. And we divide by 4, which is not a perfect number, but it's 6.25. And we're going to go ahead and square root to get x by itself. And so if we take the square root of 6.25, it's a nice 2.5. And we need to remember it's positive or negative 2.5, so plus or minus. All right, next up we have a quantity squared. And so what we want to do on this one is we want to, first of all, get rid of this -2, which is being multiplied by all of this. So what we can do is we can go ahead and divide by -2, and that will eliminate this. We divided because it was being multiplied. So a negative divided by a negative is going to be a positive, and that is 529. That leaves us 3x plus 7, the quantity squared. Now, since that is being squared, if I square root it, the squared goes away, and I get back to just 3x plus 7. Now, I have to take the square root of both sides. Anytime I do something in an equation, I got to do it to both sides. So while I'm taking it right here, I also have to take the square root of 529, which is 23. And now we're left with a very simple equation to solve. I'm going to bring it up here. No squareds anymore, so just a two-step, minus 7, so 3x equals 16 divided by 3, and that comes out to 5.3 repeated, which is 5 1/3. Now you may think we're done here, Problem is, when we take the square root of 529 over here, it's the positive and the negative version of 23. So it's plus or minus 23. So this answer could give us positive 23, and that would be the answer 5 1/3. But it also could be negative 23. So I need to solve it again, but for negative 23. So now when I minus 7, I'm going to get negative 30. And when I divide that by 3, I get negative 10. So my final answer is both of these, both negative 10 and negative 5 1/3. All right, moving on to 9.3. It says consider this function x squared plus 3. We're going to go ahead and complete the table first. So let's say we had 0. You're plugging in 0. You don't need a graphing calculator to do this. 0 squared is 0 plus 3 is 3. What about 1? 1 squared is 1 plus 3 is 4. 2 squared is 4 plus 3 is 7. 3 squared is 3 squared is 9 plus 3 is 12. Negative 1 squared, negative 1 times negative 1 is 1 plus 3 is 4. And you start to see the parabola. Okay, here's my vertex. So let's go ahead and answer that, 0, 3. And these are going to mirror each other on both sides. So this is going to be 7, and this is going to be 12. If we go ahead and graph this, 0, 3 is right here, 1, 4, and negative 1, 4, 2, 7, negative 2, 7. And then these 12s are not going to fit on the graph. So this is all we need for now. All right, so is the vertex a minimum or a maximum? So that is going to be the smallest value on this parabola. So this is a minimum. Maximum is when it's at the top, at the peak. The axis of symmetry cuts this in half, and so that is x equals 0. Domain are all the possible x values. So 0 is an x value. Everything to the right will be an x value because this will go on forever and continue this direction. Everything to the left will also be that. So the domain is all real numbers. Every number in the world will be part of the domain. The range, that's not true. So we have 4 and we have 5. We have 6 in here somewhere, 7 somewhere, 8 somewhere, 9 somewhere, 10, and on forever into the positives. What we don't have is 3 or 2 or 1. 3. Did I put this on the wrong spot? I did. I apologize. Oh no, this is 3. I just said 4. I don't know why I said 4. Okay, so we have 3, but what we don't have is 2 or 1 or 0 or any negatives. None of those are part of this function. So the largest value we have here, or I'm sorry, the smallest value we have here is 3, and the range is everything from 3 up. So the range is in terms of y. It's everything that's greater than or equal to 3. It's nothing that is less than 3. All right, moving on to 9.4. So we have some projectiles and we have the same equation that we use for these, except we have a value that we use for meters and one that we have for feet. And so for this one, we look carefully, it's using meters, and so we need to make sure we use the right equation for that. So we're going to write the formula to represent an object being dropped from a height of 40 meters. So just to bring that equation back, it's negative 4.9 times t squared, okay, plus initial velocity times t plus initial height. And so we only have one number here, and that's 40, and that's the initial height. So that's going to be 40. So it's going to be negative 4.9 t squared. There's going to be a plus 40. Now the initial velocity means if it's shot out of something, it's going to come out already having a speed. But since this is being dropped, its starting speed is 0. So you would plug 0 in here, and when you multiply 0 times anything, it's just going to clear itself out and be 0. So we're actually not going to have that middle term. It's just going to be blank, and our initial height, this, is 40. So this is our formula for the situation. What's the height after 1.5 seconds? We're going to go ahead and plug in. And if you run that out, you get 28.975. And then they're going to ask you, is it in the air after 3 seconds? So what we have to do is plug in 3 to this equation and run it out. And when you do, you get negative 4.1. So since that's a negative number, that means it's past, okay, the 0. 0 would represent the ground here because we did plus 40 for the initial height. So 40 meters up from the point we're measuring from. So 0 would represent the ground. And so if we get a negative number, that means this is no longer in the air. So is it in the air after 3 seconds? The answer is no. And it says explain how you know the height is negative or the height is less than 0. That's how they wrote it on the answer key. All right, so if we move on to the next question, basically the same idea, but this one is in feet, and this one does have an initial velocity. So since it's in feet, okay, we're going to have to use the negative 16 t squared plus the initial velocity, which is 26 times t, plus the initial height, which is 6. So there's our formula. Okay, for part B, hopefully you caught it. There's a mistake on the answer key. We're plugging in 2 for t, so it's going to be negative 16 times 2 squared plus 26 times 2 plus 6. If we go ahead and run that out, negative 16 times 2 squared plus 26 times 2 plus 6. Okay, we get negative 6. On the answer key, they said 16, but if you looked at the work, they plugged 1 in instead of a 2. So that was the problem there. Okay, so that should be negative 6. Is the object still in the air after 5 seconds? Well, I can already look at this and see, well, if it was already in the negatives after 2 seconds, that's not good. Okay, so obviously this is not going to work, but we want to show our work. So negative 16 times 5 squared plus 26 times 5 plus 6, putting the 5 in for time, comes out to negative 264. And so the answer here is no, it's negative. So the big thing is to remember that we use negative 16 for feet and negative 4.9 for meters. All right, jumping then into 9.5, using our quadratic formula. And this is when things start to get to be a little bit more work. So remember our quadratic formula, negative b plus or minus square root of b squared minus 4ac over 2a. We're going to go ahead and solve these. So my a is 1, my b is 8, my c is 7. So plugging into this, negative b would be negative 8 plus or minus the square root of 8 squared, so 64, minus 4 times 1 times c. So 4 times 1 is 4, times 7 is 28, over 2a, so 2 times 1, which is just going to be 2. So the only real math we got to start with here is 64 minus 28. That's 36. So it's going to be negative 8 plus or minus the square root of 36 over 2. Well, the square root of 36 is 6, so negative 8 plus or minus 6 over 2. And so we have to solve this two ways, once with the plus and once with the minus. So negative 8 plus 6 divided by 2, and negative 8 minus 6 divided by 2. So negative 8 plus 6 is negative 2, divided by 2 is negative 1. So that's one of the answers. And negative 6 minus 6 equals negative 14 divided by 2, which is negative 7. All right, when we come to the next one, this one's not in standard form yet. So we need to minus the 37 from both sides to get to standard form. So x squared minus 3x minus 37 equals 0. It's in standard form when you have 0 on this side. Okay, so now we have an a, a b, and a c. So a equals 1, and b equals negative 3, and c equals negative 37. So our setup here, it's going to be negative b. Well, b is already negative, so it's going to say negative negative 3, which becomes positive 3, plus or minus b squared. 3 squared is going to be 9, minus 4 times a times c. So 4 times 1 is just 4 times negative 37. So 4 times 37 is 148. And since it's minus 4 times minus 37, they're going to end up being a plus. So 148 over 2 times a, so which is just 2. So if I put these together, if I want to rewrite it here, I'm squeezing it in. It's the square root of 157 divided by 2. Now when you go to take the square root of 157, you'll notice it's not a nice number, so we're going to leave it right now and set this up both ways. So 3 plus the square root of 157 divided by 2, and 3 minus the square root of 157 divided by 2. And we'll go ahead and run those numbers. So 3 plus square root of 157 divided by 2, and we get 7.76. And 3 minus the square root of 157 divided by 2 equals negative 4.76. So those are our two answers. All right, let's squeeze this last one in here. So I've got this over here. I need these on that side. So I'm minusing 13y. I'm minusing 100 onto the other side. So when I rewrite this, I get 3x squared minus 13y minus 100 equals 0. So my a is 3, my b is negative 13, and my c is negative 100. So negative b will be negative negative 13, so that's positive 13 plus or minus. 13 squared is 169 minus 4 times 3 times negative 100. All that over 2 times a, which is 3. So as we go to work this out, I have 4 times 3 times 100. And that's 1200. There's two negatives here, though, so that's going to be a plus 1200. So it's going to be 169 plus 1200, which comes out to 1369. So it's going to be the square root of 1369. And then 2 times 3 is 6. So this is what we're looking at. Now, if I go ahead and try and take the square root of 1369, it actually is a nice number. It's 37. So really, this is 13 plus or minus 37 over 6. So all we got to do is solve this two different ways. 13 plus 37 over 6, 13 minus 37 over 6. All right. So when I do 13 plus 37 divided by 6, I get 8 1/3. And when I do 13 minus 37, that's negative 24, divided by 6 is negative 4. So those are my two answers. So notice on the answer key, when they put theirs in standard form, they move the 3x to this side. So it's just moving one thing, so it's kind of easier. It does end up to be a negative 3 then for your a, and these stay positives. But if you follow through their answer, when they did that, you notice this is not my handwriting, so someone else completed this key. When they did that, they still ended up with the same answers. So as long as you end up with something with 0 over here, it doesn't matter which way you move it. Okay, it's still in standard form, and you will still end up with the same two answers. All right, last part, 9.6. So now we're going to analyze the solutions based on the discriminant. So two parts, calculate the discriminant and then state how many solutions there are. These always need to be in standard form, and they're very nice to you here. All of them already are in standard form. So your discriminant is the part that's underneath the square root, b squared minus 4ac. So remember, if it's 0, plus or minus 0 is the same thing. So that creates one answer. If it's negative, there's no solutions because you cannot take the square root of a negative. And if it's positive, there's two solutions because there's the plus and the minus of the positive number. So the discriminant will tell us how many possible answers there are. So part A, again, we are doing b squared minus 4ac. So my a here is 5, my b is 20, and my c is 20. So b squared, 20 squared, that's 400. And that's going to be minus 4 times 5 times 20. So when I do 4 times 5, that is 20. So when I hit times another 20, 20 times 20, that's 400 again. So I end up with 400 minus 400, which equals 0. So the value of the discriminant is 0. So this has one solution. Big mistake people make is they say no solutions or 0 solutions because they got 0. But remember what this is. That means they would have got 0 under here. And when they run this, they would have done something plus 0 divided by something, something minus 0 divided by something. And plus and minus 0 gives you the same answer. And so there's just one possible solution. All right, so here, b squared minus 4ac, a is negative 4, b is 56, and c is negative 196. So we're going to take 56 squared, which is 3136, minus 4 times negative 4 times negative 196. So first of all, when I look at this, I have 3 negatives. So that's going to create a minus or a negative number. So 3136. 4 times 4 times 196 is 3136. So 3136 minus itself is again 0. And so we have one solution again. All right, and last one, a equals 2, b equals 1, and c equals negative 3. So plugging into b squared minus 4ac, b squared, 1 squared is 1, minus 4 times 2 times negative 3. 2 negatives will make a plus, so this is 1 plus something. So right away I already know there's going to be two solutions. 4 times 2 times 3 is 24. If you punch this in as negative 4 times 2 times negative 3, you get the positive 24. So the answer here is 25, and since it's a positive answer, that again means there's two solutions because you would do plus or minus 25. So one's plus, one's minus will create two possible answers.